Hello everyone, welcome back to Math with Allison. Today we're working in our integration series. We're going to be talking about work, but specifically lifting, so the work required to lift something. So let's go ahead and dive into it. We're going to use some equations here. We first have that force is equal to mass times acceleration, which we can rewrite as volume times density times gravity. So this leads us to the formula that work is equal to the integral from A to B being where it starts being lifted and where it ends being lifted. And then we have the density multiplied by the gravity, but remember it also multiplies by volume. So we find the volume by multiplying the cross-sectional areas times the distance. And we're integrating this in terms of y. So let's go ahead and talk about what this looks like with an example. We have how much work is needed to pump all the water out of a cylindrical tank with a height of 10 meters and a radius of 5 meters. The water is pumped to an outflow pipe 15 meters above the bottom of the tank. So here I already have a beautiful picture for us, and I put this on a graph because sometimes that's important and needed to find equations and stuff like that. But let's go ahead and talk about the measurements of the cylinder. So we know that this goes up to a height of 10 meters, right? And we also know that it has a radius of 5 meters. So this goes out to 5, which means that this goes out to -5. So let's go ahead and talk about what y represents. The y level, so if I took a cross-sectional right here, we would say that this is our y level, and that has to be the height of the water. It's going to be our variable because that's what's going to change, right? The water level as the water is pumped out decreases, and so that's what we're going to use as our corresponding y value. So first, let's go ahead and talk about a cross-sectional. If I literally sliced it and I took a slice of it, we would have a circle, right? And so we know some things about the circle. We know that the radius is equal to 5 meters. And so here we can find the area of the circle. We get pi r squared. And so here we would get 25 pi. So here we found our cross-sectional area A of y. The reason that it's A of y is because sometimes it's going to be a function of y. In our case, the area across the whole thing doesn't change. It's always going to be 25 pi. So ours is just a constant. Here we want to talk about the lifting distance. So it said that we are lifting up to 15 meters above the bottom of the tank. So we have 15 and we're subtracting the level of the water. So here we have 15 minus y, right? So we're going to use density and gravity. Gravity is nice. We know that this is 9.8. And we're going to use the density of water, which is 1,000 kilograms cubed. So now that we have all of these pieces of information, we're going to go ahead and set up our integral. So here we have that work is equal to, so we are starting at the very bottom of the tank, but we're only going up to 10 meters because the tank is only 10 meters, right? The water level can only be at maximum 10. So now we have our density 1,000 multiplied by our gravity 9.8. And then we multiply this by the cross-sectional area, which we got to be 25 pi. And then multiply again by our lifting distance. So here we have 15 minus y, and we're integrating this in terms of y. So here we're going to bring out all our constant multiples. We have 1,000, and I'll put this in parentheses, times 9.8 times 25 pi. And now all that we're actually taking the antiderivative of is 15 minus y. So it's not a very complicated integral. I think it's the setup that makes it confusing for people. So there we got our antiderivative, and here we can plug in upper minus lower. So when I plug in upper, we get 15 times 10 minus 10 squared divided by 2. And then when I plug in 0, we're just going to get 0. So I'll go ahead and leave it like that. And then this is definitely a calculator problem, and we end up getting 7.7 times 10 to the power of 7 joules, which is a lot of force. That's almost 10 million joules. So that right there would be our solution. So let's go ahead and try another one. This is going to be a case where the cross-section is a function of y. So here we have a water tank that's shaped like an inverted cone with a height of 6 meters and a base radius of 1.5 meters. If the tank is full, how much work is required to pump the water to the level of the top of the tank and out of the tank? So let's go ahead and talk about this setup here. I already have a visual drawn for us, but we're going to go ahead and label the coordinates. So here we know that the radius, which I'll go ahead and draw up to here, right? So that's going to be the radius, is going to be 1.5 meters. So this goes out to 1.5. And we know the corresponding height of this is going to be 6 meters. So let's go ahead and talk about what y represents. Here, y represents the water level. So let's go ahead and take a cross section. So I literally, boom, I slice it just like that. What we're going to have is a circle. But notice the circle is not going to be the same all the way up, just like it was for the cylinder. If I took a cross section on the top, it's going to be much bigger than a cross section from the bottom. And so this, our area, is going to be in terms of y. So we are going to go ahead and set up our function. So what we need to do is find the radius, right? The radius is going to extend from the y-axis out to our corresponding side. And we can find the side. It's going to be an equation because notice right here, that's just a linear line. So let's go ahead and find what that's equal to. Here we can set it up y equals mx plus b, right? We have that it stabs the y-axis at 0, so we have b is equal to 0. And we can also find our slope by doing change in y over change in x. So we go up 6 meters and over 1.5. So if we wanted to rewrite that, we have 6 divided by 3 halves, which we can write as 6 times 2 over 3. And that's just going to be equal to 4. And so here our equation is y equals 4x. But remember, we want our area, the cross section, to be in terms of y. So we need to solve for x. We get y divided by 4 is equal to x. So here we have that our radius is equal to y divided by 4. And now we can plug that in. We get pi times y divided by 4 squared. So we have our area. We want to go ahead and find our distance in terms of y. So here, when we're lifting it to the top of the tank, we're lifting it 10 meters. So it's 10 minus whatever the water level is at. That's how far we'll be lifting it. And then for gravity, again, that's going to be 9.8. And our density is water, so that's going to be 1,000 kilograms cubed. So let's go ahead and set up our integral. We're taking the integral between 0 and 10. And here we're going to multiply all these things in. So we have 1,000 times 9.8 times our area, which is pi over 16y squared, times our distance, 10 minus y dy. So let's go ahead and bring out all these constant multiples. We get 9,800 times pi over 16, the integral of 0 to 10. And here, let's multiply that y squared in. So here we get 10y squared minus y to the power of 3. Now we can go ahead and take the antiderivative. Here we can plug in upper minus lower, right? And so when we plug in 0, that's just going to be 0, so we can ignore it. So let's just plug in 10. And so this right here is equal to 207,816.408 joules. I went ahead and plugged that into a calculator in order to get the final solution. So now we have another part to this. Is it true it takes half as much work to pump the water out of the tank when it's filled to half of its depth as to when it's full? So let's go ahead and talk about what this would look like as an equation. We have work is equal to we have the integral, but instead of going from 0 to 10, because that's the water level, the water level is only until 5. So here we're integrating between 0 and 5. But everything else in this equation stays the same, right? So here we have 1,000 times 9.8 times our cross-sectional area did not change. So we get pi over 16y squared. And again, we're lifting it to the same height in order to get it out of the tank. So that doesn't change. So let's go ahead and talk about what this will equal. So here what we're going to do is we're going to plug in 5. When we plug in 0, that's just not minus. That goes to 0. Okay, so here we got 64,942.6275. Notice that this is not at all half of the work. If it was half the work, it'd be around 103,000, right? In this case, it's not going to be true that it takes half the amount of work, right? And so we proved why. When we integrate between 0 and 5, it's much smaller than half, right? So that's all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.